Hello and welcome to your own channel, Geography for Success. And once again, I'm here with a new topic, that is atmospheric pressure and winds, which is a very important topic at this level. In 9th, 10th, 11th, 12th, and in even the competitive exams also, this topic is very, very important. So let's continue with it. And as we start with this topic, I want to remind you once again, if you like this video, don't forget to share this with your friends and subscribe the channel. And one more thing, you should press the bell icon also so that you will get the notifications whenever any video is uploaded in the channel. So let's start with it. First of all, atmospheric pressure. What is atmospheric pressure? What is meant by atmospheric pressure? By the name only you must have got some idea. The pressure which is exerted by atmosphere. Okay, here we are talking of the Earth's atmosphere, and over the Earth's surface, the pressure which is exerted by the surrounding atmosphere, surrounding gases which are present in the atmosphere, that is called as atmospheric pressure. As you all know it very well, there is a thick atmosphere surrounding the Earth. It is almost 1500 kilometers thick atmosphere is there with several gases within it. So if the gases also have their own weight, so if all these gases are present in the atmosphere and these are actually getting attracted towards the Earth's surface by the gravitation force which is actually working from the center of Earth. So what is the result of it? All the weight of all these gases actually exert their own pressure over the Earth's surface. And all this pressure which is exerted by the various gases or the atmosphere as a whole, that is only called as atmospheric pressure. And this atmospheric pressure basically, it is very, very important element in the studies when we do related to the weather conditions or the climatic conditions of a place, because this is a factor which influences several other weather elements. Now we have to discuss all these things in detail in this chapter. Now first of all, as we start with this, the instrument which is used to measure the atmospheric pressure is called barometer. Barometer. And with time, with the development of various technology and all, we have also got different barometers at different periods. And the basic concept behind all these barometers is the same. You can see in front of you, it is shown with the help of a simple barometer. The picture is shown to you here. Now in this picture, you can see in this figure, especially the simple one beaker has been shown to you, and it is filled with mercury. It is half filled with mercury, and one glass tube you can see which is actually placed over it. When we place this glass tube over the mercury and we observe now what is the level of mercury in the glass tube, whenever you will find the surrounding air, right, surrounding atmosphere is having more pressure, it will exert the mercury down, okay, from the surrounding area, and that mercury will rise in this glass tube, okay, going higher and higher. So in this manner we can check the level of mercury which has come up in the glass tube, and when we measure it, that can be taken as the atmospheric pressure of that place at that particular moment, at that particular time. You can take the example here. It is actually shown the atmospheric pressure here at the mean sea level, right? At the sea level, generally it is 760 millimeters or 76 centimeters of mercury level. In this way we mention, okay, 76 centimeters or 760 millimeters of Hg, which is a symbol of mercury. So as the mercury level rises, that means the atmospheric pressure is rising. As the mercury level goes down, that means the atmospheric pressure has decreased. So the maximum atmospheric pressure is considered at the mean sea level. As we go higher up, always the atmospheric pressure decreases. That we are going to discuss further in the next topics. And how does it affect the movement of winds? Whenever the atmospheric pressure is more at one place and some other area, the atmospheric pressure is less, always the winds start blowing from the higher atmospheric pressure area to the area which is having low atmospheric pressure. So it is one of the reasons behind the movement of winds also. So the atmospheric pressure is actually the weight exerted by a column of air per unit area on a fixed time is called the atmospheric pressure. At any particular place, whatever column of air is there on per unit area, how much the weight is exerted by that air is called as the atmospheric pressure of that particular place at that time, okay, that fixed time. And always it is measured with the help of an instrument called barometer. Just a picture of that you can see here. This is barometer. Now it is generally measured in the unit which is called bar or millibars. And over your right side you can see, children, one more picture is there, actually the map of India. And over the map of India, a few lines you can see. Can you see all these lines? All these lines are actually called the isobars, right? Isobars, ISOBARS, isobars. Now what is an isobar? Isobar is a line which joins the different places having the same atmospheric pressure. Suppose we say any isobar is of 100 millibar, right? Its value is 100 millibar. What does that mean? That particular isobar connects, it joins all the different places having exactly 100 millibar of the atmospheric pressure. And this way the isobars help in actually giving us an idea about the pressure conditions of different regions, right? Whenever these isobars come closer to each other, that indicates the pressure gradient is very steep. The pressure gradient is very steep. Pressure gradient is actually the rate of change in the atmospheric pressure between the different isobars. And when we see here, you can see, children, here both the examples can be taken. Along the coastal parts, along the eastern coast especially, if you see here, the isobars have come very close to each other. What does that mean? This indicates the pressure gradient. Okay, when they come closer to each other, that means the pressure gradient is very steep. On the other side, you can see here in the interiors or the plain areas, the pressure gradient is very gentle, because the reason is the isobars are far off from each other. The distance between isobars is more. So here you can see in the interior parts of India, the pressure gradient is comparatively gentle. Now what is actually what we can interpret out of it? This indicates always the movement of winds. Okay, the movement of winds are going to be at a faster speed or it's going to be at a slow speed. That is getting very clear with the help of this pressure gradient. If the pressure gradient is steep, keep this in mind very clearly. When the pressure gradient is very steep, that indicates always that the winds are going to blow with a faster speed. You will find the stormy conditions may arise or the winds blow with a very fast speed. As compared to this, if you come to the other areas, suppose in the interior parts of India, in this map especially, you will find, because the space between all the different isobars is more. So this, because of this, it indicates that the gentle gradient is there, and this shows that the winds are going to blow with a very slow speed. So in this way we can easily relate, with the help of atmospheric pressure, the speed of winds. So in this way, children, different weather conditions get affected by the atmospheric pressure, temperature, and all these elements. Now, what is the importance of atmospheric pressure? First of all, children, just now I have told you that whenever the atmospheric pressure is clear to us, right? Whenever atmospheric pressure is more, that means the winds are going to blow from the high pressure area, and wherever it is less, towards that area. That means from always a high pressure area, the winds start blowing towards a low pressure area. And how does it get affected? Suppose atmospheric pressure is influenced a lot by temperature. Whenever there is a change in temperature, whenever temperature is very high, it will cause the pressure to get very low. Whenever it's very hot, pressure will be very low. And the other side, if the temperature is very low, it will make the pressure to go very high. So this is one of the basic points which actually influences the atmospheric pressure, and atmospheric pressure influences the movement of wind. Okay, as the pressure variation is there, that actually results into the movement of air, which is called as wind. When the air is at one place, that is the gases which are present at one place, that is air, it is standstill. When it starts moving, that is called wind. Horizontal movement of air is called wind. Now the next thing is how the winds can be important for the other things, suppose for causing precipitation and all. You can see the second point which is given here. The winds actually transport the heat, and whenever they carry heat from one place to the other, that results into the you can say the change in the rate of evaporation, and it influences the precipitation also in different parts. Naturally, if the evaporation rate will get affected, it is going to affect the precipitation also. So this is why it is considered as one of the most significant factors in influencing, or you can say when we forecast the weather conditions of any place. This is one of the basic factors which we take, that is the atmospheric pressure. And then we can relate the other things with it, and we can get a clear idea about the weather condition of that particular place. Now, how the air pressure or the atmospheric pressure gets affected by temperature, height from the sea level, or any other factors, right? Let's discuss these factors. How the temperature influences air pressure. Whenever I just discussed that with you in the earlier part, whenever temperature increases, right, that means it's very hot, always that makes the pressure to go down. Why? Because whenever temperature rises, children, the surrounding air gets also hot, and if the air gets heated up, it will always get lighter in weight and it rises up. As the air will rise, it will leave back the space, and this makes the area to have a low pressure area. So this is how whenever temperature is high, it makes a low pressure area to develop there. Just opposite thing happens when the temperature is low, or you can say it's a cold condition. What happens then? When it's low temperature, children, always the air also gets cooled, and when the cool air is there, it always starts settling down because it gets heavier in weight. Okay, so when it settles down, naturally it is going to cause the pressure to go high, and that's why it is said that temperature, when the temperature is low, always it makes the pressure to go high. Now the second factor is height from the sea level. Now whenever we are, suppose, at the sea level always the pressure is maximum. Okay, over the sea level always the pressure is maximum. But as we go higher up from the sea level, as we go higher up with an increase in altitude, you will find the pressure decreases. You can say at a higher altitude over any hills or mountains, you will find the pressure has decreased. What is the reason for that? Reason for that is, as we go higher up, the amount of air, the atmosphere, the density of atmosphere, you can say, is getting less, because density of atmosphere is maximum over the sea level, right? Over the, you can say, at the lower heights closer to the earth's surface, it is maximum because of the gravitation force of the earth. Maximum part of the gases get attracted towards the earth's surface, and this is the reason the density of atmosphere is maximum close to the earth's surface. So if density is more, naturally it is going to have more atmospheric pressure, and as we go higher up, the density of air gets less. And as we go higher up, because density of air has become less, naturally it is going to exert less pressure at that height. This is the reason why as we go higher up, with increase of altitude, there is a fall in the atmospheric pressure. There is a decrease in atmospheric pressure. Now let's see the next factor. Next factor is the moisture in air. Next factor is the moisture in air. Whenever the moisture of in the air is more, it will cause less pressure over the earth's surface. It will exert less pressure. And whenever the moisture is less, it will exert more pressure. That you can understand in this way, children. When you will find the water vapor is more in the atmosphere, okay, water vapor content is more, so that will apply more pressure. Next factor is the humidity in the air or the moisture in the air, right? What is that? The amount of water vapor which is present in the atmosphere, that is called as the humidity level. Okay, that makes the moisture to go high or low. Now whenever the water vapor content in the air is more, it will exert less pressure because it has got less weight. Why? Because you know the molecular weight of the moist air, okay, molecular weight of the water vapor, or you can say the moist air, then is comparatively much lesser than the dry air. Okay, molecular weight of moist air is always less than that of the dry air. Now the next factor which influences the atmospheric pressure is the gravitation of earth. And as we suppose we are close to the earth's surface, because the gravitation pull is maximum from inside, that is from the core of earth. The next factor which influences the atmospheric pressure is the gravitation of earth. Now always the gravitation of earth, we all know it very well, that it is exerted from the center of earth, that is the core of earth. And as we go away from the core, gravitation force will become less. And as the gravitation force will become less, naturally the pressure will become less. So whenever we are, suppose, at the minimum distance from the core of earth, we are going to have more atmospheric pressure there. And as we go higher up and up, there you will find the atmospheric pressure keeps decreasing. Same way, you just think of one more condition is coming out here. We know that the shape of earth is geoid. The polar diameter is less than the equatorial diameter. So the poles are comparatively closer to the core of earth as compared to, if we compare that with the equatorial region. On the equator you will find the distance is more from the core. Then if you measure the distance between the pole and the core, that is the center of earth, it will be much less. So naturally it is closer to the core, so it will have more pressure. I hope this much is clear to you. Now come to the next one, rotation of earth. Rotation of earth is actually causing an effect in the form of centrifugal force, because we all know that the rotation of earth is there on its own axis, and the rotation, when this movement goes on, always the maximum centrifugal force is experienced over the equator. As compared to that, if we move towards the poles, because the poles are the axis over which the earth is rotating, and over the axis the centrifugal force becomes very less, or it becomes almost zero. And so this is the reason what happens there on the equatorial region, that the air, because of the rotation of earth, the air which is present in that area is thrown out. It is thrown out because of the centrifugal force. The air is thrown out from the earth's surface, away from the earth's surface, and this is actually causing a very you can say low pressure area to develop over the equatorial region. Always it is working more over the equatorial region as compared to the polar region. So naturally polar region is having more pressure than the equatorial region.